To achieve theater quality projection, be sure your picture is pre-focused before the show starts. First, focus your lens carefully on this chart. Many lenses will not give a sharp image all over the screen, so make sure the central area of the screen is sharp. Now adjust sound volume and tone control to achieve the most pleasing and clearly understood voice quality. If the room is empty, keep the volume a shade high. When the audience enters, their clothing will soak up some of the sound volume. Now, if you shut off the projector, when the white dots flash on the screen, the picture will be in starting position. That's all, and thank you. It is 6:59 p.m. Eastern Standard Time. And 93 United flights are traveling the mainline airway. At 1 minute before 7, it's twilight in New York. Westward in Chicago and the Midwest, it's an hour earlier. At Denver and Salt Lake City in the Mountain States, it's only 5 o'clock. And on the Pacific Coast, from Washington to California, the sun still stands high above the horizon. Far out over the Pacific, a plane nears the Hawaiian Islands. And heading east, a homebound flight approaches the airport terminal. 93 routine flights at a given moment, carrying people and their goods through 5 time zones, across an ocean and a continent to their appointed destination. But near the city of San Francisco, there's a special destination which appears on no timetable nor on any flight schedule, to which no passengers or cargo are carried, but at which every mainliner has a very special appointment that cannot be broken. "14 miles due south of San Francisco, the orderly buildings of United Airlines maintenance base stretch out along the airport road. This is the destination which appears on no timetable, where every mainliner has a standing appointment, an appointment with dependability. This base, the largest and finest in the world, stands as a symbol in steel and concrete of the determination of 3,000 men and women who work here, that in terms of dependability and performance, no mainliner will ever grow old. To meet such exacting standards, our maintenance base must be a large operation, constantly growing and expanding as our fleet of almost 200 mainliners expands and grows. By night as well as day, the planes arrive. Whether they're 4-engine or twin-engine, the massive maintenance docks are ready and waiting as the planes move in on time schedules as precise as if they were on regular scheduled flights. And the object of their appointments, eternal youth.
Eternal youth, yes. But here at the base where we do the job of keeping them young, we call it preventive maintenance. It's a logical and reasonable process, we think, taking care of our equipment. Before our friend here started to fly, before she was even born, we knew that she would be in to see us about every 4 months, just about what we'd have to do to take good care of her. It's all worked out on cards. What has to be done, when it has to be done, and just exactly who is going to do it. It was planned that way a long time ago for today by the very same men who are now planning for tomorrow's age of jet transports. They have to determine which future design will best meet Mainliner's standards of dependability and what added facilities will be needed here at the base to ensure those standards. To analyze high-speed operations at 40,000-foot altitudes, we've been flying a jet airline on paper from San Francisco to New York and return each day, complete with flight plans and regular dispatch procedures. 500-mile-an-hour jets will be pretty expensive. Putting 10 of them in service will take close to $50 million. With an investment like that at stake, recommendations made here had better be pretty close to right when they go to the President and Board of Directors for approval. The VP for Engineering and Maintenance wants a report on the progress of the equipment planners. The General Manager of Engineering says that the manufacturers are being receptive to our suggestions based on operating experience. The next report comes from the General Manager of Maintenance. The base is tied in. New facilities are well developed and will be able to handle the jets. His assistant wants advice. What's the word about the problem of new tooling for the engine shops? That's under control and being taken care of. Men planning for tomorrow. But how can you see men thinking? How can you tell by a facial expression the years of experience and hard work on which judgment is based? Only one way, really, by results. Results achieved by those who plan and by those whose skill and know-how turn plans into action. Maintenance policy, in addition to providing for preventive maintenance operations at the base, also provides for the regular day-by-day line maintenance out in the field at every airport on the system. After each plane lands and discharges its passengers and cargo at the airport, it's subjected to a series of line inspections as thorough as they are routine, each one specified and controlled by company maintenance manuals. Check the propellers. Take out a battery, then put a new one in. Need a new tire? All right, put it on. And of course, inspect it. Always inspect every detail, none too small, none too large. Then sign for the work you have done and the job you have inspected. In keeping with sound principles of dependability, day-by-day line maintenance at all the airports is coordinated and carefully tied in with policy and operations back at the maintenance base. The procedural instructions for line maintenance are compiled and issued in the Service Engineering section. We could call this the Voice of Experience Department, where the youngster in point of service has had only 14 years of practical airline experience. The average for the section is well over 20 years per man. And though planes fly on wings, in the maintenance analysis section, they fly on paper too. Here, the daily in-service reports of every mainliner are analyzed in relation to peak performance, so that out in the maintenance docks, peak performance can be ensured by progressive maintenance operations at the regularly scheduled appointments about 4 months apart. After keeping 8 of these appointments at the base, every mainliner is, to all intents and purposes, a new airplane. But that's the idea of preventive maintenance. Keep them new and better than new by constantly incorporating improvements and developments, many of which are conceived and designed by our engineering groups, whose knowledge is based on practical as well as theoretical experience. To redesign parts to suit our requirements, to adapt new electronic devices for our own specific needs, we produce more than 3,000 different parts ourselves, even though we are a maintenance operation and not a manufacturing one. This means that in many cases we must also design the tools to make the part to fit our standards. But though we design and make some 3,000 items, they are all parts of only one product, dependability. But before we can make the parts, we must check the flow of work against facilities in the shops, scheduling each machine for each particular job. But no matter how good the plans or how expensive the equipment, they alone cannot turn out a single part. They need the touch of fingers skilled to tools and the knowing eyes of many years and long experience. The machines are there, but it still takes good men to run them, to run the lathes, to operate spot welders that in one electric surge weld metal tight to metal, to check, to gauge, to measure tolerances held to 1/10,000th of an inch. And the lessons of experience are passed from old-timer to apprentice, so that younger hands and eyes can, in their good turn, carry on the traditions of craftsmanship and quality. And where one man's job ends, another man's job begins. While some work indoors in the shops, at the same time, others on the ramp outside the docks use a chemical wash on every plane as soon as it reaches the base. This is really a king-sized bath, and there can be no let-up on the schedule of dependability. Through 4 days and nights, the planes stand in the docks as the work goes on, changing, replacing, renewing. All 4 engines are removed on every scheduled visit to the base. They will be replaced later with other engines, completely rebuilt to new condition. That, in turn, takes other machines and other skills. Over at the engine shop, the power of 2,400 horses dwarfs the tiny truck that tows it in. Soon this intricate miracle of precision engineering, $54,000 worth, will disappear before your eyes, dismantled into its component parts so they can be cleaned, smoothed, polished, reworked, or replaced to be finally reassembled and reappear as an engine which, in terms of performance and dependability, is as good as new. Now, when only the crankcase and an empty stand are left, stack the small parts neatly into baskets. Let the larger ones stretch out in orderly single file for a slow and thorough journey through the cleaning plant. And 5 hours later, when the parts come out, take the shining metal and inspect it. Check it, work it, and inspect again. Time is not the factor here. Speed comes not from haste, but from skill and care and pride of craftsmanship. To rebuild an engine takes a lot of men, a lot of equipment, and the resources of a large and experienced organization. Down on the final reassembly line, the separate parts will meet again, will reappear in the form for which they are meant. 18-cylinder double wasp engines, powerful and dependable. They are almost ready to flex their muscles. Almost, but not quite. First, they must be tested in a building especially designed for that purpose. On the test stand, they will run for 5 hard hours under conditions and power loadings far more rigorous than any they will be called upon to meet in actual flight. Back in the docks, the cabin overhaul crew are stripping down the cabin so that it too can be made like new again, so that its walls can be scrubbed and cleaned, that every fixture can be checked and worked over in keeping with its needs. Masking paper goes on walls for the bright new paint. Radio equipment and instruments come out, and so do all the seats for a short trip to the upholstering department, so that for the long trips ahead, they can be recovered and renewed to provide the same full comfort for which they are designed. In a way, it's odd that the flying needles of a battery of sewing machines should add so much to the flying comfort of an airplane. Work by machine and work by hand. In the radio, instrument, and electrical shops, the precise and delicate touch of the craftsman can only be described by the tolerances to which they work. Tolerances measured not in thousandths or even 10,000ths of an inch, but calculated in electronic wavelengths. Here, earthbound technicians fly automatic pilot systems under realistically simulated flight conditions. They fly the instruments and check the equipment, working with earphones, a soldering iron, a microscope, living and working on the ground, but sending their delicate instruments off into the air, into the 3 dimensions of winged flight. The intricate mechanisms we call propellers are also disassembled. Blade by blade, they are taken apart so that their component parts can be examined, reworked, or replaced if necessary. After all the components have been tested and proven to be in new condition, they can be reassembled again into the recognizable form of a propeller, so finely balanced that it can be set in motion by the touch of a fingertip or by the simple turn of a control, shifted through all its ranges from full high power to full reverse and back again. Work a propeller, and up in the sheet metal shop, work the metal, for regardless of department or job classification, the effort is toward a single goal, dependability. These are the men from almost every state in the Union, here because of their skill, from Maine, Montana, and Minnesota, here from Ohio, Oregon, and Oklahoma, because they know the work is worthy of their strongest effort. Though the efforts of the base are concentrated in every different corner of its million square feet of working area now, soon the results of these efforts will meet down in the massive docks. And when the cushioning action on the landing gear is checked and marked OK, it's ready to be wheeled away, to go back to take its proper place, so that in turn its functioning can be checked again on the plane itself. OK when operated electrically. Now how about the hydraulic operating system? OK on that one too. Coordination and teamwork start to show results as the plane takes form again. The outside metal gets trimmed up, and the inside trim receives its final coat. A different spray prepares the nacelle to receive the engine, and further over, on the other wing, the flaps have been installed again. Check their movement up, then throw the flap control lever in the pilot's compartment to try them out the other way. Inspectors follow every move and every operation. And now the tempo seems to speed up, but only seems to, because as in the shops, speed comes from organization and not from haste. Now the first of the 4 giant engines swings high upon the hoist to move past the broad expanse of wing and take its place upon the plane. In spite of its great size and weight, there is no hesitation, no wasted effort. These men, just as the men around them, know how to do their jobs. While they move the engines into position and connect them, others bring the seats back from the upholstery department to their designated places. Air conditioning units are checked to ensure low altitude comfort during high altitude flight. Inspections go on and on, so that by the time a Mainliner leaves the base, every square inch will have been inspected at least several times. And now the work inside the dock is almost finished. All that remains to be done are the last few touches, the final scrutiny of inspectors. Off comes the masking tape from paint now dry. In go instruments and radio equipment. Inside the cabin, one final check of the soundproofing material. Then all that's left is to roll out the carpet and to sign out the plane as ready to leave the dock. Like a ship being launched, she moves slowly down the ways. After 4 days and nights of concentrated effort, each step planned, each one executed according to plan, on time, on schedule. 4 days and nights inside the docks, but there are still 2 days more to go outside on the ramp. In the bright light of day, ramp crews and inspectors check on the checks of other inspectors again and yet again. But it's only reasonable that this attention to detail should be as it is, because precision all along the way is the only way to be sure that after 8 scheduled visits to the base, all Mainliners look and function in every detail like the new airplanes they really are. When all the inspections and work are over, it's up to the planes to prove that their performance as well as appearance match up to the rigid standards of dependability. Helping them prove it is the job of the test flight crews, who, between them, fly more than 1,000 test flights every year. Before a test flight, the flight engineer makes the final visual inspections all around and under the plane. This is routine before all flights as well as test flights. At the same time, the co-pilot checks the action of the control surfaces, which are operated by the pilot in the cockpit. The co-pilot signals that response is proper and correct. Now a few brief words with the chief test mechanic and the test flight starts. there is no feeling of tension or excitement. This is routine procedure to pilots, some of whom have flown almost 2 million miles of tests. They are truly flying engineers whose office is not in any building, but up forward in the pilot's compartment.
During the next hour and a half, the flight test crew will try and analyze every detail of the Mainliner's flight characteristics under normal flight conditions, and also under conditions which will reveal her tremendous reserves of power and performance. Now, at the head of the runway, the engines get their pre-takeoff run-up. Then United Test Flight cleared for takeoff. Take off normal. Ease back the power for the climb up into the regions of an almost private world where the sun is always shining. Here at 16,000 feet, the speed of 300 miles an hour seems just a camel's pace, and faraway places only a few moments away, beyond that lazy cloud just a little bit ahead. But in the cockpit, there's work to do, tests to be made. Test flight procedures and operations are all planned and scheduled, and they are carried out in the exact sequence prescribed in advance. Now, the next test on the schedule is coming up, the analysis of the reserves of flying power. So the pilot hits the propeller feathering button to cut out engine number 1. Everything okay. So stop the number 2 engine. The power of the engines and features of design are such that normal climb can be maintained with only 3 engines, and level flight with any 2. Periodically, permanent records are made of instrument readings with a Polaroid camera. When the pilot is convinced everything's going as smooth as silk, he resumes normal flight. Now there's time to check the photo of the instruments and then file the information away for future reference and analysis. Planes fly on paper, even in the air. Certainly no other private office in the world with a view quite like this, and very few which function with greater methodical precision. Fingers as sensitive as a concert pianist's trim controls to test flying stability with hands off all controls. Up at 16,000 feet, any day is a good day for flying. The air is smooth, the clouds in stately rank drift by below. But the test crew in the cockpit have no time to taste the beauty that is just outside their windows. Their satisfaction comes from 9,600 horses purring smoothly, the story told by the instruments on the panel, the prompt and positive response of every control, even in maneuvers far more extreme than any used in normal flight. Check and counter-check until they know that all that remains is to return to base and officially sign out their plane as a good plane and ready for service. But the test crew also know that tomorrow they and other test crews will be checking other mainliners through these same standards of dependable performance, made possible by 3,000 men and women working together with that sure confidence that comes from knowledge and experience, using a pencil, a drill, a lathe, checking gear, propellers, valves. 3,000 men and women who share a common pride, knowing how to keep an airplane perpetually young, perpetually new, to carry flying colors along the 13,250 miles of mainline airway. It's almost evening now on the Pacific coast. From coast to coast, across a country and a nation, at a given moment, 93 United flights in the air at the same time are carrying people and their goods through 5 time zones, across the Pacific Ocean, and across a continent to their appointed destination.